than 90% of the global warming generated by carbon emissions is absorbed by the oceans. And researchers at UNSW Sydney have discovered that ocean warming has accelerated dramatically since the 1950s. For more, we're joined by Professor Matthew England from UNSW Sydney. Matt, welcome. Great to have you with us today. Tell us about your findings.
Yeah, so what we did is looked at the ocean temperatures over the last 50 years using all available measurements as well as model simulations. And we found out that over this period, this amazing amount of warmth has been absorbed by the ocean. So more than 90% of the heat we've trapped in the planet from increasing greenhouse gases has gone into warming the oceans. There's a couple of percent in the atmosphere, a couple of percent as melted ice, and so on. But the vast majority of the energy trapped by greenhouse gases can be found in the oceans. And what we also did was go into these model simulations to try to work out, which ocean has led the charge. Was it the Pacific or the Atlantic or the Southern or the Indian? And it turns out the Southern Ocean has done the lion's share of the work. About 80 or 90% of that big amount of heat uptake has come into the oceans in the Southern Ocean, and it's made its way northward from that starting point.
So that's fairly interesting that the study found that the rate of ocean warming just isn't the same everywhere. How does that happen?
Yeah, no, it's a very good question. Basically, the oceans take up heat wherever it's cool enough at the surface so that the atmosphere above is warmer. The oceans won't take up heat. If the oceans have already warmed at the surface, they're not going to take up more heat, okay? So in a way, you need to go to a bit of the ocean where you continually renewing the surface water with cooler deep water and putting that surface water, subducting it, putting it into the deep ocean elsewhere. And so the Southern Ocean has an amazing machinery. We have these westerly winds that circle Antarctica, and when they blow over the ocean, they basically push this surface warmed water into the interior, and that means the ocean's ripe to take up more heat because you're basically removing the warmed water, putting it into the deep ocean, and enabling the ocean to take up more heat. In other ocean basins, unfortunately, once you warm the surface, it relatively stagnates there, and you don't sort of have a situation where you can take up more heat. And so it's really about getting that heat into the interior. Now, it sounds like a good news story that the oceans are taking up heat. Unfortunately, when they do this, they also raise sea levels, they melt ice, and so on. So there's a payback to this uptake of heat, but certainly you need the oceans to bury that heat to get it away from the atmosphere.
Now, your findings also predict where we go to from here. So tell us about those predictions.
Yeah, so ocean warming is going to continue, and that will raise sea levels and ice melt, as I mentioned. And exactly which ocean basin takes up that heat. It looks like the Southern Ocean will keep leading the charge because of these westerly winds that circle Antarctica. It's the perfect setup to push this warmed water deep into the ocean and then enable the oceans to keep taking up that heat. So in a way, we're going to see more of the same. Really what the future holds for us is set by our carbon policies, though. So whether we go to a high end of climate change, a high end of sea level rise, depends on where our carbon emissions go to. At the moment, we're on track for a very significant amount of climate change, and that's why we keep talking about having to reduce our emissions to bring down the rate of sea level rise to limit the number of changes that we're going to see around the world from climate change.
What happens, Matt, if we meet Paris Agreement emissions targets and global surface warming is limited to 2 degrees above the pre-industrial levels? What happens if that scenario is in fact the truth?
It'd be a great thing to happen because all of the likelihood of these climate thresholds being breached, they come right down. So we have much lower likelihood. For example, a good place to look at is the West Antarctic ice sheet. We know from past climate, when we take the planet's temperatures above that 2 degrees C threshold, in past climate states, the West Antarctic ice sheet has been decimated by that level of warming. And we have about 5 meters of sea level locked up there. And so the chances of us breaking up the West Antarctic ice sheet and leading to that 5 meter sea level rise, which by the way takes out Sydney as a viable city. It takes centuries to get there, but it's still an amazing loss of infrastructure to lose a city of the scale of Sydney to this ice melt. And so that's why we keep talking about Paris. It's a level. It's not actually necessarily a safe level of warming at 2 degrees Celsius. We still have worse bushfire seasons. We still have a lot of impacts that cost society. But those very catastrophic levels of climate change, like melting a whole ice sheet, the chances of that happening at a 2 degree C level of warming are much, much lower than if we take the planet's temperature to 3 or 4 degrees Celsius of warming.
Can we actually stop or I suppose reverse, if we do meet those emissions targets, can we reverse the ocean warming that we've seen so far?
Yeah, no, it's actually very hard to reverse, and we sort of don't want to reverse it. So if that ocean warmth got back into the atmosphere, it would mean much, much higher warming in the atmosphere, which brings bushfire seasons and horrible droughts and intensified flooding systems and so on. So in a way, burying the heat's good, but we do get sea level rise from it. It's a very non-reversible process. Once you get that warm water into the ocean, it's away from the atmosphere. It means you can't get the heat back into the atmosphere very easily. And actually where that water goes to, it takes centuries to thousands of years for that water to eventually resurface where it would release the heat back to the atmosphere. So a lot of these environmental problems we've faced over the last century are reversible. You go and clean up a waste plant and you get benefits straight away. We get benefits from reducing our emissions, but unfortunately these processes like ocean heat uptake, they're not reversible. Once the heat's got into the interior, it's there for millennia. It raises the sea level, and that sea level, once it's raised, takes millennia to then to stabilize, and it's not really reversible. We won't see climate of the early 20th century again in any of our lifetimes, and probably not for thousands of years. But where we take climate change to is set by these emissions. So if we meet Paris, the changes sit here, and we can probably cope with them. If we breach Paris several times over, we get to catastrophic levels of climate change that are terribly costly to society. For generations to come, they'd be dealing with sea walls, coastal flooding impacts, bushfires, and all these bad impacts of climate change.
And we're talking about the impact on biodiversity, of course, within our oceans as well at the same time, and that impact is significant, is it not?
No, absolutely. Coral reefs are under threat. Even at 2 degrees Celsius warming, a lot of our coral reefs will be bleached and be lost effectively forever. Some coral reefs would remain at that level of warming. The higher we go, the more a lot of these ecosystems in the oceans have temperature thresholds. Some, they can adapt. Fish will migrate to higher latitudes. All these things can adapt, but it's a big jolt to the system. And that's why we're seeing worldwide biodiversity threats. A lot of ecosystems adapt to extremes and harsh conditions in weather. Those events of a couple of days can be tolerable. If you permanently change the climate to a different temperature state, that can see extinction rates jump up for a lot of ecosystems.
So Matt, this is a very, very serious topic with huge implications for all of us. It doesn't matter where we live. Do you have any good news to share with us today in terms of the type 100%. Of research you've been doing?
It's really important to talk about, though. So thank you for asking that good news question, because one of the things I always come back to is that decarbonising is a massive boost it will be a massive boost to our economy. We'll see a growth in the renewable sector. We'll see a growth in a bunch of new engineering projects to bring new energy systems that are low in their carbon footprint. Virtually every sector will need to respond to this problem, but it will lead to a growth in innovation and jobs. And if we just sit doing the same thing, digging up more coal and just burning it, that doesn't create jobs. We're actually seeing a decline in jobs, and it's not good for the economy just to sort of keep burning fossil fuels. It's actually better for the economy to go to this low carbon technology, to grow a new economy, and we'll see a big boom. There's a lot of work to be done to decarbonise. That means a growth in jobs and a growth in the economy. And I think people often worry that we're saying we've got to abandon our way of life. It's not at all the case. There's just so many good ways to make energy that don't require carbon. And we've got those technologies at our fingertips, wind, geothermal, solar, battery storage. All these technologies are mature and ready to go. We just need to scale and produce them massively across the world.
Matt, thank you so much for sharing your expertise and your time with us today. We do appreciate it.
Great to join you. Thank you.
Professor Matthew England with us there from UNSW Sydney.